Okay, in this problem, we're going to look at another optimization problem with some geometry in it just to get some more practice. What we have here is an open box with no lid, and we're going to have a square base. So that means that this side right here is a square. Okay, that's going to be some helpful information. We know we have 675 square feet of material to construct the box, and we want to know what the maximum volume is. So I guess the first thing we have to really figure out is what does this information translate as? If you think about making a box, you're making the sides. And that means that we have 675 square feet of surface area. So we know that the surface area is 675, and we want to maximize volume. So we have some things to fill in here. Well, let's just take a look. So we know it's a square base, so I'm just going to call the lengths of the base x. We know it's x by x. And since the height is not guaranteed to be the same as the base, I'm going to have to call it something different, so I'll call it y. And just like that, we have everything we need. We know volume is the length times the width times the height, so that's x times y, which is x squared y. So that gives us one expression. We know the surface area is 675. Well, that's a little bit more complicated. We have one side that's a square, and that's the base. So we know that that area is x squared. In fact, I'm going to write that here. And we have four sides that could be x by y. And that's, this side piece here, this side piece here, the front and the back. So there's four of those. So that means that the surface area is x squared plus 4xy, and that's equal to 675. So this is already proving to be a very interesting problem because here's the function we want to maximize. And I'm going to assume that we want to replace y. So we're going to replace y by whatever it is in terms of x. And that we're going to get from the constraint equation, or in this case, the surface area. So let's take 675 equals x squared plus 4xy. And since there's only one y, we did kind of luck out there. We're going to solve this for y, so I'm going to subtract x squared from both sides. And I'm going to divide both sides by 4x. And what I'm actually going to do is I'm going to rewrite that because we know that fractions are much more simple if we just have them term by term. And, would you look at that? X squared and x can cross out in the second term. So I'm actually going to go ahead and write that. So this is x over 4. So that means this right here is going to go right here. And then multiply by x squared. So boy, this problem is really taking on a whole new meaning here. So my volume function with respect to x only is x squared times 675 over 4x minus x squared times x over 4. And if I multiply the x squared through, well, x squared over x, that leaves me with an x in the numerator, so that's 675 over 4x minus, well, I'm going to write it as 1/4 x to the third, and that's my volume function. So now that we're here, we can use calculus to analyze this. So this is getting a little better by the minute here. So v prime is equal to 675 over 4 minus, now if I bring the 3 down, that's 3/4 x squared. And we know that the action happens when it's equal to 0. Okay, so you can either multiply both sides by 4, that could work, or I'm just going to add the 3/4 x squared to both sides, whatever. So we have 675 over 4 equals 3/4 x squared. I'm actually going to go through and multiply both sides by 4/3 to get the x squared by itself. And what that gives me on the left-hand side is, well, the 4's, whoops, I wanted them to cross out, but not that quickly. The 4's will cross out. 675 over 3 is 225. These cross out, which gives me x squared. And yeah, luck would have it, x is the square root of 225, which is 15. So that means this is a critical number, which means something likely happens here. It's probably going to be a maximum. So let's just see what happens, though. So thinking about the problem, how we verify that it's a maximum, we have a lot of different ways we can do that. We could plug in different values to the volume function, or we could use the first derivative test, or we could use a second derivative test. So just for variety, I'm going to take the second derivative. And notice for the second derivative, it's really easy to do that because my expression is really simple here. So derivative of 675 over 4, that's a constant, so that derivative is 0. The derivative of negative 3/4 x squared is negative 3 halves x, right? Because the 2 times a fourth is a half. And then if I take my second derivative at 15, I get negative 45 halves, which is negative, which means, remember what second derivative tells us, that tells us about concavity, so we know that our function, our volume function, is concave down, and since we plugged in the point where there's a critical number, it has to be the max. So we've just verified that there is indeed a maximum at x equals 15. So let's answer the questions. The original question was, what is the maximum volume? Well, the maximum volume, we know that the maximum occurs at 15, so we'll call it V max is equal to, well, what was our volume function? The volume function was this one here, so it looks like 675 over 4 times 15 minus 1/4 times 15 to the third. And yep, my handy calculator is there. 675 over 4 times 15 minus 1/4 times 15 to the third. And that gives us 1687.5. And that would be, are we measuring in inches or feet? I can't remember. I think we are talking square feet. So we're making it's a big box. Probably for shipping or something. Now, one step we could take further is, what if I ask for the dimensions? There's a lot of ways you can get there, but let's just, try to keep it simple. So we know that x is 15, so that means the dimensions of the base are 15 feet apiece. So the question is, what is that y? Well, we have a couple ways to do it. We know the volume is 1687.5. And we know that 2 of the sides are 15, and we don't know why. So we could just say, just take the volume and divide by 15 times 15. And that should be, so if I divide that by 225, y is 7.5. You could also take the constraint equation. We know that the constraint equation was a surface area, which was 675. Is x squared plus 4xy. But we also know that x was 15. So 675 equals 15 squared plus 4 times 15 times y. And then if we solve that for y, well, let's see, subtract 225 from both sides, we get 450. And divide both sides by 60, yes, we do get 7.5. So again, there's many ways of getting the same answer. So dimensions, if it were asked for, I know I didn't ask for it at first, you could say 15 feet by 15 feet by 7.5 feet. And there we have it. So hopefully that was another helpful example of how to construct your own function and then analyze it. I will keep posting more as you want, and thank you for watching, and stay tuned.